Hey, welcome back to the next little piece. Let's take a look at 11 through probably 14 or 15. We'll see how this goes. I did find a mistake in this thing, so we're going to have to fix that. So let's see. So problem 11 immediately asks you about something about this angle relationship. And these are what we call vertical angles. In fact, not only is this one an example of vertical angles, so is problem number 12. So we're going to use our knowledge, and we happen to know that in the case of vertical angles, that they are always congruent. And if they are congruent, then that automatically means that they are equal to each other. So if we're to subtract 3x from both sides, and then we added 5 to both sides, we'd have 30 equals 3x. And I found out that x was 10. Now, in this particular case, it's just said solve for x, so I guess we're done. But it wouldn't be bad to plug it in. 6 times 10 is 60, minus 5 is 55. 3 times 10 is 30, plus 25 is 55. So it looks like we did great. They actually match. I used the number I got to confirm that they were, in fact, congruent. Now, similar to the last one, I know it's a little redundant to put this on the review, but if they're vertical again, they are equal. If they're vertical, they're the same. So let's subtract 5x from both sides. I had a little bit more room on this one, so I'm going to go ahead and show those steps. Let's subtract 10 from both sides. So again, once it becomes algebra, it should become fairly comfortable. And again, I just wanted to find the value of x, but again, 12 times 3 is 36. 36 and 10 makes 46. 5 times 3 is 15. And 15 plus 31 again is 46. So that confirms that the value 3 actually was successful in making it work. Okay. Now, this is the flaw that I mentioned. It's actually, I believe, correct originally, but somehow when I printed it, the font was really small. There's supposed to be a square right here and right here, that you're supposed to subtract those values and square them, and that doesn't look like it's clear. So if we're going to use the distance formula, we're supposed to take the second x, which is 2, minus the first x, which is 10, and then we're supposed to square that. And to that, I'm supposed to take the second y, which is 10, and I'm supposed to subtract the first y, which is -5, and square that. Now, I did that very much on purpose as I designed that, because you're going to notice that we have a double negative. So 2 minus 10, in fact, is -8. But 10 minus -5 is actually 10 plus 5, which is 15. Now, I'm going to go ahead and do this on my calculator, because -8, if I square that, gives me 64. And be careful, because remember, you're really taking all of -8. Oops, I don't know what I did right there. I'm just going to take all of -8 and square it. And then I'm going to take all of 15 and square that, and I got 289. Now, that doesn't mean they're 289 units apart. It means it's the square root of 289. And that's a very nice answer, 17. So the distance between those two values is 17 by the distance formula. Now, number 14, we just wanted to double check that everybody's ability to do the Pythagorean theorem, which remember was a squared plus b squared equals c squared. But c is always the hypotenuse. So keep in mind, you got to be a little bit careful, because we could put it in different orders. So a squared plus b squared equals c squared. So I got 49 and 64. So now 49 and 64 add up to 113. But I don't want to know what c squared is. I want to know what c itself is. So c would be the square root of 113, which we can either leave it as the square root of 113, or we can ask our calculator for a decimal approximation of that. And I got 10.6. So remember, this is being rounded off, and that's why I'm using the approximate symbol. That it's not a perfect easy number. Like this one right here is a nice perfect easy number. This one is not so much. And my last one, number 15 for this particular video, number 15. Notice I made a little bit of a more difficult problem for you, but remember the Pythagorean theorem, C is always the hypotenuse. So that means I would say something like a squared plus b squared equals c squared. Let's do through the math here a little bit. That's 144. If I subtract the 64 from both sides, I get 80. And so that means this side here is the square root of 80. So let's see, I could say square root of 80, or I could simplify it a little bit and make it a decimal. I'm not usually a fan of decimals. I like root 80 a little bit better, but there is a reason I like 8.9 for this problem about. And that's because the hypotenuse is always the longest side. So 7, 8, well, that makes sense that this is longer than both the 7 and the 8. 8, 8.9, 12. This makes sense that the 12 is longer than both of those sides. So that kind of finishes up through number 15, and I'll have a separate video on this last problem, which is the proof. I'll see you back here for that one later. Bye-bye.